Good morning, good evening, good afternoon, boys and girls. So today's lesson is about SD-WAN. We're going to talk about Cisco SD-WAN. This is a new technology that has been evolving during the last couple of years. And we're going to talk about overlay, control, and data planes for CCNA certification and real-life scenarios. So let's go with the lesson. First, this is the agenda that we have for today. We have introduction to SD-WAN, why SD-WAN is needed, SD-WAN components, overlay concepts, control plane, data plane, orchestration plane, real life scenarios, comparison with traditional WAN implementations, and finally some summary and exam tips. So let's go. What do you think is SD-WAN? Have you ever heard about it? So when we're talking about SD-WAN, we're talking about software-defined networks. And that is basically a virtual WAN architecture that is securely connected to users and applications. So software-defined WAN is a virtual WAN architecture that securely connects users to applications. It improves performance, agility, and reduce costs. That is SD-WAN. Now, when we're talking about traditional WAN challenges, these are some of the challenges that have come up during the last couple of years. Mainly, we refer to high MPLS costs, complexity in management, inefficient cloud access, and limited flexibility. Some of the benefits that we have for SD-WAN are, and I'm going to use the highlighter here so you can follow along with me in this section. Centralized management, we have secure connectivity, optimized cloud performance, reduce costs, and application-aware routing. So those are some of the benefits that we finally get from SD-WAN, implemented SD-WAN solutions and technologies. So let's go ahead and clear the board. Let me remove this and go back to the red color. Let me continue. SD-WAN architecture. When we're talking about SD-WAN architecture, it consists of 4 planes. The management plane, known as the vManage is the management plane. The vBond is the orchestration plane. The control plane is the vSmart, and the data plane is the edge routers. Those are some of the components or some of the planes related to SD-WAN architecture. Now, what is overlaid network concept? Overlaid is a virtual network built on top of an underlay, MPLS, Internet, LTE, LTE, you name it. It provides abstraction, segmentation, that's a difficult one to pronounce even for me, and security. So overlay is a virtual network built on top of an underlay, for example, MPLS, Internet, LTE, and it provides abstraction, segmentation, and security. That's the overlay concept. Now, there are some of integration that we have here with the control plane, and it is basically the administration by the vSmart controllers. Some of the benefits that we receive are it establishes control connection, it establishes security control connections, it distributes routing information, and it defines policies for traffic forwarding. So when we are working along with the vSmart controllers, we establish secure control connections, distribute routing information, and it finally defines policies for traffic forwarding. Let's continue moving on. Those are some of the benefits of the vSmart controllers. Let's clear the board and let's continue moving forward. The data plane that is basically managed by edge routers, and it forwards actual users' traffic, applies security policies, and performs application-aware routing. The vManage provides some of the following. We have a centralized GUI or CLI, a template-based provisioning, and a monitoring and troubleshooting. So those are basically the ones that we have with the vManage um, integration, basically. When we're working the management plane and we're adding the vManage, we get the centralized GUI all in one place in a single view, connected, and the administration of all components, the template-based provisioning, and the monitoring and troubleshooting as well. This is used in NOC, Network Operations Center, when you are doing monitoring for networking alarms. So Network Operations Center, and that is an example of real life if you want to take notes. They usually have this vManage integration with monitoring tools and the management plane in order to monitor any possible problems in the network. And it actually creates automatically alarms that are generated by the system, and then they convert these alarms into tickets, and that's the way it works. Let's clear the port and let's continue moving forward on this. Now, orchestration plane. What do you think about orchestration plane? What comes to your mind when we are talking about orchestration plane? So the vBone orchestrators, vBone orchestrators, that's a difficult one for me. It authenticates edge devices, facilitates secure connections, and provide scalability. That's basically what the vBone orchestrators do. Authenticate edge devices, facilitate secure connections, and provide scalability. Let's clear the board and let's continue moving on. Some of the secure fabric and the secure overlay fabric. What is it? How does it work? All components from a secure encrypted overlay across one links. This allows multi-cloud and branch connectivity. That's basically what we get with the secure overlay fabric. Okay, interesting. Let's go ahead and clear the board and let's continue learning about these concepts. Many of these work with automation and Python and all the integration for example, the networks through automation and Python. And even the artificial intelligence is getting a lot of strength during the last couple of years with these integrations. Okay, we have the traditional WAN versus the SD-WAN, and we can see the differences. For the traditional WAN, we are talking about static, expensive MPLS, and complex. Now, when we move forward about the SD-WAN new solutions, we get centralized control, we get a dynamic integration of systems, and it uses internet and MPLS and new technologies that are evolving during the last couple of years. We can name just a few of them. I'm trying to remember some of the new technologies that we have, plus the MPLS integration with SD-WAN, and I don't remember them at this moment from the top of my head. I might have to do some research and investigation of those for future chapters. But for now, you get the idea. SD-WAN is more proactive, dynamic. It uses internet plus MPLS. It's a centralized control, single glass point of view where you can do the administration for everything. Even technologies like vendors for like Meraki, you can do the administrations for routers, switches, cameras, access points in a single point of view monitoring system. And that's the way that SD-WAN is coming along during the last couple of years and that integration. Let's go ahead and clear the drawing. And this is the first example of an enterprise network. We have the headquarters. Let's say we have a router over here, and that is HQ. in New York, New York. And that is connected through uh, an ISP, which is actually Verizon. And then they actually have the MPLS integration to another branch, which is in, let's say, Arizona. And they have the MPLS integration, and they have the internet, and they have an SD-WAN monitoring system at both locations. So they have SD-WAN here at the headquarters, and they have an SD-WAN there. And they are doing some Meraki technologies. So they are monitoring other networks, and they are automating other networks with Meraki. So that's a little bit of an example of the way this works in real life. We have headquarters, we have branches, we have the cloud connected SD-WAN fabric, we have a dynamic path selection, and this is just the first example of the SD-WAN implementation and the way it works. So let's clear the board and let's continue moving on. Policy informants. When we're talking about this is the control plane and all the functionalities that it defines per se, like rules for administration of traffic. And you can talk about app prioritization, security policies, quality of services, data plane enforces them. So that's a little bit about the policy enforcements and the way the control plane defines these rules for quality of services, security policies, prioritizations of different apps, and the data planes enforcing all of them. Let's go ahead and clear the board and let's continue moving on. What else do we have? Okay, application aware routing. What is it? How does it work? What comes to your mind when you're talking about application aware routing? SD-WAN chooses the best path per application, per app. We can talk about voice, MPLS, Office 365, Internet, and finally backup LTE. Those are basically, depending on the application that you are running, it will choose the best option. In this case, we can have internet, we have MPLS, we have LTE technologies. So it just depends on the technology and the applications that you are currently supporting. What else do we have? Let's continue. Let's clear the board. Security in SD-WAN is also an essential and important part. We're talking about IPsec, end-to-end encryption, segmentation, secure onboarding, and threat detection. That's some of the benefits that we finally get from SD-WAN technology. Now, moving along, clearing the board, what is cloud integration and how does it work? It provides an optimized access with the SaaS applications. It gives us the direct optimized access to SaaS applications, SaaS apps, for example, Salesforce, AWS, Azure, GCP, and Office 365. So these are the examples of applications that are integrated in our day-to-day basis and daily works, daily functions, and they are integrated with the cloud. Many of the famous ones are Azure, supported by Microsoft, and AWS, that is supported by Amazon. Finally, this is another example. We have, let me just clear the board for a moment, a retail chain. This is a real life scenario. And we have a store that connects securely to HQ and cloud apps over a broadband, reducing the cost versus MPLS. So there is like a store here. Let's just name it like Amazon, for example. Let's just name it Amazon. Amazon, and this is the branch in, what can we say? In Florida. This is the branch in Florida. In Florida. So let me just work on this, Florida. And this branch connects to a router, and then it connects to an ISP, to another router, and then it connects to the cloud, to the ISP, and then finally it connects to some server. There's a server that has some applications. In this case, it has Office 365, for example, Office 365, and it has Salesforce integration. Okay, and you get the idea, the big picture. You are connected router to router, then you connect to providers, and you connect to the servers and the different applications. And they are using some broadband technology, and they are using MPLS. Instead of MPLS, they're using broadband. So it depends in the application that you're currently using, if you will be using LT technologies, MPLS technologies, Office 365. So it will basically depend on the applications. So let me go ahead and clear the board for now. Let's continue learning about this. Real life scenario, remote workers. This is a very common one and is actually evolving during the last couple of years, working from home. SD-WAN ensures secure connectivity for remote users with dynamic path optimization. This is another example, a healthcare. We are talking about hospitals. Hospitals share patient data securely across branches with encryption and redundancy. And finally, we have some tips and recommendations for the exam, the CCNA certification exam. So, exam tips. Understand overlay versus underlay. Know the planes, control, data management, app orchestration. Focus on policies versus routing. And remember benefits and use cases. Interesting. Maybe we can study a little bit more about underlay and overlay later on so we can have a better picture of that. Let me just go ahead and write it in my notes so we can have that handy. And summary, SD-WAN modernized WAN by separating overlay from underlay, centralizing control, and securing connectivity. Maybe we can ask our friend GTP chat to give us a picture of the underlay versus overlay so we can have a better example of that. For ZCNA certification exam, please create a picture explaining underlay versus overlay. I'm going to add this maybe in the presentation so you can guys have this information. And also if you have questions, you can always reach me via the classroom and ask for any questions that you have whatsoever, and I will be glad to help you. So we're trying to understand the overlay versus underlay. So let's just say overlay versus underlay. Underlay. That's the first thing that we're trying to do. So we want to have like a picture or a better understanding of what is overlay, what is underlay, and how does it work. Maybe we can find it in the guide. I'm going to look it up in the meantime to see if I can find it in the books. Give me just a moment here. The DNA guide. This should have the example. Let me go ahead and see if I can just look it up here. Let's do overlay, overlay versus underlay, underlay. Let's do overlay. No, it's not there. Let's wait for the picture for now because I'm trying to find it here in the guide, but it doesn't really have much information. Okay, I can see something here, but what I'm trying to get is like a big picture of this. What about this one? Mm, it's basically the core layer, the distribution layer, and the access layer. But what I'm trying to understand is like a picture with the differences between underlay and the overlay. This is the data plane, this is the control plane, this is the API and the scripts. And this is the LDN architecture. The way it created is that we first have the scripts, then we have the APIs, then we have the controller and the control plane, and then down below you have the data plane. The southbound interface connected to the northbound interface, and this is the big picture. You basically get the big picture of the SDN architecture. So this is like a brief introduction. Let me just clear this drawing for now. The northbound interfaces, the reason we access SDN controller through NVI is so we can deploy SDN to get something done for us. And most of the time, we do that via GUI, in Meraki, or through RESTful API called inside a script. The southbound interface. Now, I said southbound interface SVI is how SDN controller actually talks to the network. And there are lots of different ways it can do that depending on the specific solution. For example, Open Daylight, a popular open source SDN controller, it uses protocol called OpenFlow to talk to switches. On the other hand, Meraki uses a proprietary solution right now since they manage everything themselves. Okay, so that's basically it. Let me see the picture, and we finally got it. So on the underlay, we have some switches that are connected to the local area network, and that's basically the customer network. Then, what is the overlay? These switches are connected to an ISP, and they are connected to the cloud, and they are getting some access to the internet. So that's a little bit of an example of the internet versus the customer local area network and the integration of overlay and underlay. I'm going to do the following. I'm going to save this picture so you guys have it available. Let me close this. I'm going to add it to the presentation that we have been working along today. At the end of the section, maybe I add a new slide. And let me just work on that. Let me copy this picture and paste it there. And the name is overlay, overlay versus underlay, underlay. So you can have a better picture and idea of what is underlay, what is overlay, how does it work. I'm going to work on that right now. So that's what I'm doing at this moment. Okay, I got it. I got it. I'm going to add it in the slide number 24. Let me just save this. Let's see if we are missing anything. And the automation. We'll pretty much cover everything today. Okay, so the Cisco DNA Center. This is a Cisco main enterprise SDN controller, and we will explore it soon. That's what it says. Okay, the integration for the S controller, SDN controller. We have the control plane over there, and we have that it connects to the data plane and another data plane via trunking. And that is the way SDN controller works. Let's go ahead and clear the board for a moment, and let's read this last definition to close for today's chapter. Let me highlight it in light blue for now. So another way is the Cisco Wireless LAN Controller is another management tool, another administration where they have the access points all connected and being managed by decentralized controller. And that's another example of SDN controller. Cisco SDN solutions like Digital Network Architecture, DNA Center, and we'll talk about that later on this chapter. So probably we will cover this in future lessons. I'm trying to see if there is like an example of this. We get the core layer, distribution layer, and the access layer for the campus fabric, the spine and leaf architecture. And this is basically spines and leaf. And the way it behaves is that the spine switch is a lot like core because its sole job is to provide super fast transport across leaf switches because leaf switches only connect to the spine switches, not to the leaf switches. Traffic is really predictable since all destinations in the traffic follow the same path, leaf, spine, leaf. Because everything is 3 hops away, traffic is easily load balanced in the routing table via equal cost load balancing ECMP. And finally, we get the SDN network, software defined networks. That's what we were talking about, the underlay and the overlay. The underlay has its own components. We have NTU, interface config, OSPF and IS config, and verification. This is an example of an underlay topology. Underlay job is to carry a lot of traffic with larger packet payloads that you'd normally see in a standard network. Because of this, it's good to understand the idea of NTU on the underlaid switches so the larger packets don't give you any drift. And this is the size of the MTU. It's configured with the command system MTU. The interface configuration, we are talking about underlaid at this moment. Then we get all the configuration for the interfaces, the protocol for OSPF, the OSPF protocol, the ISIS protocol is not here, but you get the idea. And finally, we get the overlay. Basically, an overlay is a virtual network that's tunneled over underlaid devices. This allow us to have SDN controller with strict control over the traffic running through the network. The type of tunnel being used varies depending on the exact SDN solution, but generally is virtual extensible LAN, VXLAN being used. VXLAN is the way tunneling connects to layer 2 traffic over layer 3, and this allows you to connect VLANs across router networks, but the details are above the CCNA level. So you only have to understand the main picture, the main idea, the main functions of underlay and overlay, and in order to fully understand deeply, this will be covered in CCNP and CCIE level, but you start getting the basics and the fundamentals for overlay. Finally, let's just go ahead and read the last section of this. The overlay is where the advantage configurations like security and QoS gets introduced into the network. The underlay has no visibility into the tunnel network, so it can effectively do things like filtering traffic. Routing for the overlay is usually handled by BGP or EIGRP. Going with link state protocols is a bad idea because they require all devices in an area to have the same LSAs. Plus, you can easily improve the routing table with summaries, etc. Dynamic multi-point virtual private network. DMVPN is a very popular type of overlay that runs under the WAN. In this topology, each brand connects to the hub router through DMVPN across using the 10.100.123.0/24 network, allowing us to run the IGP across the internet to provide that all important consistent routing factor, DMVPN actually offers lots of advantages, but for now, check out figure 22.24. That is a simple example of an overlay. So let's see if we can see that figure. Nice. So you can see this example. You can see the DM VPN topology, and you can see all the integration of the different devices. You can see the ISP over here. You can see branch 1, branch 2, and branch 3. It is connected to different local area networks, and it is connected to an internet service provider. And then there is another hub that is running DM VPN technologies. And this is basically an example of the DM VPN topology. Great. Finally, just to recap, what is the fabric? The fabric, the network fabric is actually the simplest thing in this chapter to understand. It's really just a shorthand term for all the layer 3 network devices, routers, switches, firewalls, wireless controllers, access points involved in a solution. We can refer to the network as a fabric when we are talking about SDN because the network details are abstracted by the SDN controller. And let me clear the drawing for a moment. Let's continue moving on. And finally, just to close this chapter, to put it in another way, a fabric is a simple high-speed layer 3 network. The motivation behind this trend is that IP networks scale better than layer 2 networks because we don't need to work a bunch of complex engineering magic to get around STP limitations. Also, layer 3 isn't usually so risky when it comes to misconfigurations because the SDN controller dynamically builds and maintains the underlay and overlay networks for you. So we will cover more of these chapters and definitions later on. Probably we will be doing some labs, so all of these concepts will be clear for you guys to fully understand them in real life scenarios with Packet Tracer. And it is required. If it is required, we will look into more advanced labs. But for now, this is everything for today's lesson. If you don't understand some of the concepts, you can always do some research via GTP chat or Google, and also review the class as many times as you need in order to fully understand these concepts. Also, I already shared these books with you, most of the books, so you can go over to the book, read the chapter, do it that in a relaxed way, in a calm manner. That's pretty much everything. I'll see you at the top of success, boys and girls. It's been a pleasure. And until next class, my name is Cesar. Take care.